An overview of Cloudflare's logging pipeline. One of the roles of Cloudflare's observability platform team is managing the operation, implementation, and maintenance of our internal logging pipelines. These pipelines are used to ship debugging logs from every service across Cloudflare's infrastructure to a centralized location, allowing our engineers to operate and debug their services in near real time. In this post, we're going to go over what it looks like, how we achieve high availability, and how we meet service level objectives while shipping close to a million log lines per second. All right. Now, I want to stop here and just let everyone know not everybody ships a million log lines. We're covering this to learn, but I don't want you to think that you have to replicate their thing to handle your logs. If you're doing 1,000 lines per second, that's a completely different thing than a million lines per second. All right. So we're going to learn from it, but not every problem is the exact same. Just trying to make sure that we're clear on that. Logging itself is a simple concept. Virtually every programmer has written hello world program at some point. Putting something to the console like that is logging, whether intentional or not. Sometimes it's not intentional. Sometimes you leak keys this way. Logging pipelines have been around since the beginning of computing itself, starting with putting string lines in a file, or simply in memory or industry. Our industry quickly outgrew the concept of each machine in the network having its own log to centralize logging. So what they're saying here is, like, in a distributed network, it's a pain if you have to go to each machine. So especially where you have several services that could handle the request, first you have to find which machine handled the service, and then you have to go to that machine. How do you find which machine handled the service? You could just have to check them all, which that would be ridiculous. Or, you have some way to know, like a centralized logging stack and metrics. To centralize logging and to provide scaling behind a single machine, we use protocols such as BSD syslog protocol to provide a method for individual machines to send logs over the network to a collector, providing a single pane of glass for logs over an entire set of machines. If you guys haven't seen it, there's a vector project I think is pretty cool on this topic. Pretty fast, too. Our logging infrastructure at Cloudflare is a bit more complicated, but still holds these fundamental principles. In the beginning, logs at Cloudflare started the same way as any others, with a print line. Generally, systems don't call print line directly, however, they outsource that logic to a logging library. Systems at Cloudflare use various logging libraries such as Go's Zero Log, C++, KJ Log. I've never used KJ Log, or Rust's appropriately named log. However, everything that is able to print lines to a program's standard out, standard error streams is compatible with our pipeline. This is an important thing if you're ever doing this. Make it standard out and standard error. That way, no application has to change. There's no specific logging library support. It's the best way to do logging. I have seen things where it's like, oh, use our logging library, and it's all like special, and don't do that. Make it easy on yourself. Use standard out, standard error, and it just works. It just works. You can drop in a new pipeline and you don't have to change the tools that you're using in your code. This offers our engineers the greatest flexibility in choosing tools that work for that. Right. Yeah, I mean, a new team goes with a new language is used. You got to move to Rust because you realized Go sucks, and you're now screwed because your library was in Go. Because we use systemd for most of our service management, those standard out, standard error streams are generally piped into systemd journal, which handles the local machine logs. With its rate limit burst and rate limit interval configuration, this gives us a simple knob to control the output of any given service on a machine. This has given our logging pipeline the colloquial name of the journal pipeline. However, it's like they have a distributed log. They need to, come together. I'm sorry. However, as we will see, the pipeline has expanded far beyond. Okay, come on, let's get into it. Syslog ng. While journald provides us with methods to collect logs on every machine, logging onto each machine individually is impractical. We already covered this. Absolutely. To this end, the next step of our pipeline is syslog ng. Syslog ng is a daemon that implements the aforementioned BSD syslog protocol. In our case, I am surprised I read that. I am proud of myself. You guys can say whatever you want. I read that fairly fluently. It's like I know English. In our case, it reads logs from the journal D and applies other layers of rate limiting. So this rate limiting is interesting. They've talked about it a couple times now, and I'm not quite sure. I guess they're just limiting from the individual machines to the centralized server. That's my understanding at this point. It then applies rewriting rules to add common fields, such as the name of the machine that emitted the log. Okay, this is actually also really cool. If you're doing a logging thing and you want these centralized logs, this is really important because what happens is you search over the logs, and if your application doesn't inject the name of the machine, which it shouldn't inject, it shouldn't know the name of the machine, it shouldn't care what machine it's on. It's this thing that then applies that tag. And, if you're talking about something like Loki, which is another cool project around this, you can add these tags to the things and be able to search that way as well. So in your centralized thing, you can search by machine, you can search by time, you can search by, you can get logs by a bunch of different metrics. And what this does is it basically says your application and your library doesn't need to know those types of things. The machine itself that's collecting it, in this case, their syslog-ng, is adding those things itself. Very useful. All of this stuff, I take it back. At the beginning of this, I said, they're going to do it for scale and you don't have to. These are very good things if you're in a distributed system where your application is not a monolith. If you're a monolith, you don't have to really care because it's on one machine. I mean a monolith with a single machine, or maybe two or three. But any fairly distributed system, any Kubernetes, this type of thing is really important and really good. The name of the data center and the machine is in, it has the data center. I mean, like the region, if you were in a cloud and whatnot, and the state of the data center that machine. It wraps the log in a JSON wrapper and forwards it to our core data servers. Journal D itself is an interesting feature that makes it difficult for some of our use cases. It guarantees a global ordering of every log on the machine. While this is convenient for a single node case, it imposes the limitation that Journal D is single-threaded. Bum, 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 bum. This means that for our heavier workloads where there are millions, see, I screwed up that sentence. I can't read that fast. I'm just making up words. I literally guess the next word, and sometimes I get ahead of myself. This means that for our heaviest workloads, or heavier workloads, where every millisecond of delay counts, we provide a more direct path to our pipeline. In particular, we offer a Unix domain socket that syslog-ng listens on. This socket operates as a separate source of logs into the same pipeline that the journal D log. This sounds complicated. Don't do this. But allows for greater throughput by ensuring the need of a global ordering that Journal D enforces. Logging in this manner has a bit more involved than outputting logs to the standard outstreams, as services have to. Yeah, I was going to say this. This means that you can't just you actually have to pipe them to these things. Okay, so this is only used in certain services. That's interesting. So they have two different ways to log. That sucks. I wonder if they could get Journal D to allow you to flip some setting, to be multi-threaded and not ensure order. And the management overhead that this requires. That sounds like a lot. Our logging pipeline, the history. Our logging pipeline. I don't know why I said that. I had a joke, but it didn't go. And I realized that right as I was saying it. Our logging pipeline is a critical service at Cloudflare. It should be a critical service. Logging and metrics should be some of your most critical infrastructure. Most well thought out. If you have those two, you know what's coming before it comes. Before it hits you in the face and your services go down, you might know that there's a problem. Otherwise, without these, you're kind of just driving with a blindfold on, literally. Any potential delays or missing data can cause downstream effects that may hinder or even prevent the resolving of customer-facing incidents. Because of this strict requirement, we have to offer redundancy in our pipeline. This is where the operation we call logx comes into play. If you remember right, they had an outage earlier this year where they had an entire data center go down. They did mention in that their logging and metrics were part of the very redundant service that could be on any data center and didn't actually ever go down. So that is cool that actually worked, even though their main data center went down. We operate two main. I was talking about it. We operate two main core data. I know oddly a lot about how Cloudflare operates. And their Europe one was the one they tried to fail over to, and that got screwy. Anyways, we operate two main core data centers, one in the United States, one in Europe. From each machine, we ship logs to both of these data centers. We call these endpoints log A and log B. Ooh, they ship both. Every machine ships to both the US and EU. My goodness. We ship logs to both of these data centers. We call these endpoints log A and log B. The log A and log B receivers will insert the logs into a Kafka topic for later consumption. Okay, so they're just, as they ship these logs, they're just shipping them into Kafka. This is kind of a kudos to Kafka that they can handle billions per second. By duplicating the data at two different locations, we achieve a level of redundancy that can handle the failure of either data center. The next problem, and this they did actually prove work. Their main data center in the United States went down. I wish I had the recording for that episode. The next problem we encountered is that we have many data centers all around the world, which at any time, due to changing internet conditions, may become disconnected from one or both core data centers. Wow, I didn't realize that. If the data center is disconnected for long enough, we may end up in the situation where we drop logs to either A or B receivers. This would result in an incomplete view of logs from one data center and is unacceptable. Logx was designed to alleviate this problem. In the event that syslog-ng fails to send logs to either log A or log B, it will actually send the logs twice to the available receiver. The second copy will be marked as actually destined for the other logx receiver. When a logx receiver receives such a log, it will insert it into a different Kafka queue known as the dead letter queue. We then use Kafka Mirror Maker to sync this dead letter queue across the data centers that was inaccessible. I don't understand. This. There's a picture though, so maybe this sounds like if it can't reach both, it sends another one to both. But if it can't reach both, how is that going to make it there? Am I missing something here? I have to be missing something here. All right, let's see this. Edge server, service journal, D, system log ng. So this is what I don't understand. It's saying it can't reach either of these data centers. Thus, it will send another message to either of these data centers. Am I missing something here? I feel like I'm missing something here. If this green ones goes down, what makes them think the red ones will go through? The dead letter queues are here. The B failover receivers. These are the dead letter queues. They graphed it going to the same data centers. Like, oh, let's see. Okay. The next problem we encounter is that we have many data centers all around the world, which at any time, due to changing internet conditions, may become disconnected from one or both core data centers. So they're trying to solve for both core data. I have got to, one second. We're going to really quickly draw this out. If you have the core data centers here, A and B, and this is the other data center that's shipping logs, and you get disconnected from both, it doesn't matter if you send a redundant entry because you're disconnected from both. Now, if their statement was that there was a disconnect from this one, and that it was just, but if you're saying that you're purely disconnected from these core data centers, if the data center is connected for long enough, we may up in the situation where we drop logs to either the log A or log B receivers. This would result in an incomplete view of our logs in one data center and unacceptable. Okay, now in the event that a single data center goes offline, this does work. In the event that a single data center goes offline, so let's say the US core went offline, the dead letter queue would go here. which then would mirror over here so that this one would be caught up. It's basically, you know how in Raft the leader had the ability to catch up a follower. That's basically what they're implementing here. But if they both disconnect, that doesn't solve that. And that was part of their condition here. Okay, well, they have a flaw, I think. I'm not smart enough to catch their flaws. Maybe they didn't write it that there's some edge here that's catching the dead letter queue. But they said the failover receivers are in their data center, so maybe it's outside of their data centers. I don't know. That could be the case, and then maybe that makes more sense. When logs arrive at the core data centers, we buffer them in a Kafka queue. This provides I really do like Kafka. I know it's terrible and awesome at the same time. It's kind of like Kubernetes. If you have the need for it, it's awesome. But it's also Kafka. Firstly, it means that any consumer of the logs can be added without any changes. They only need to register with Kafka as a consumer group on the logs topic. Secondarily, it allows us to tolerate transient failures of the consumers without losing any data. Because the Kafka clusters in the core data centers are much larger than any single machine, Kafka allows us to tolerate up to 8 hours of total outage for our consumers without losing data. This is proven to be enough to recover without data loss from all but the largest incidents. I think they're referring to the one. They had one. When it comes to partitioning our Kafka data, we have an interesting dilemma. Rather arbitrarily, the syslog protocol only supports timestamps up to microseconds. For our faster log emitters, this means that the syslog protocol cannot guarantee ordering with timestamps alone. To work around this limitation, we partition our logs using a key made up of both the host and the service name. Because Kafka guarantees ordering within a partition, this means that any logs from a service on a machine are guaranteed to be ordered between themselves. Unfortunately, because so basically they have a using the service and the machine and the timestamp, they can get the order of that the logs happen for that service. Not necessarily between that service and another service on the machine, which if you're doing microservices correctly, there shouldn't be a requirement for that. So that's good. Unfortunately, because logs from a service can have vastly different rates between different machines, this can result in unbalanced Kafka partitions. Oh, cool. Oh, cool. Open telemetry logs. Awesome. I hope they release something on their open telemetry logs. Ooh, storage. Okay, so storage should be interesting because if you're hitting 1 million lines per second, that's a lot. That's a lot. Even if it's just text. With the logs in Kafka, we can proceed to insert them into a more long-term storage. For storage, we operate 2 backends, an Elasticsearch Logstash Kibana, the classic Elk, and a ClickHouse cluster. For Elasticsearch, we split our cluster of 90 nodes into a few types. This seems like a lot. I know I say 1 million lines, but 90 nodes is a large cluster. I wasn't expecting it to be this large. I was expecting like 10. The first being the main nodes. These nodes act as the Elasticsearch masters and coordinate insertion into the clusters. We then have data nodes that handle the actual insertion and storage. Finally, we have an HTTP nodes that handle HTTP queries. They didn't tell us how many of each. So they have 3 different types of nodes. They have the leaders, they have the data nodes, and then they have the HTTP nodes that handles the incoming traffic. Traditionally, in the Elasticsearch cluster, all the data nodes will also handle HTTP. So they basically just split their data and web traffic, which is smart. The data ones can then be geared and designed towards that data, whether that's more drives or whatnot. And the HTTP ones can be putting those PCI slots to network. That makes sense. It's smart. If you're designing this, it makes sense. On the ClickHouse side, I've never used ClickHouse. Who's used ClickHouse? Is it good? We operate a 10-node ClickHouse cluster that stores our service logs. We are in the process of migrating this to be our primary storage. So they're moving to ClickHouse instead of the Elk stack. But at the moment, it only provides an alternate interface to our same logs in Elasticsearch provide, allowing our engineering to use either Lucene through the Elk stack or SQL and Bash scripts through the ClickHouse interface. So they just replicate both of them. Cool. I think this is what's next. As Cloudflare continues to grow, our demands on our observability system and our logging pipeline in particular continue to grow with it. This means that we're always thinking ahead to what will allow us to scale and improve our experience for our engineers. On the horizon, we have a number of projects to further that goal, including increase our multi-tenancy capabilities with better resource insights for our engineers, migrating the syslog ng pipeline towards open telemetry. It's a good step. Sampling rather than our tail sampling rather than our probabilistic head sampling we have at the moment. Better balancing of our Kafka cluster. So I feel like this is part of the open telemetry. I feel like open telemetry should help them balance their Kafka clusters. This is very interesting to me with the tail sampling rather than the probabilistic head sampling. I would love for them to do a write up on that. I think there's a lot to learn there. It's a good article. Yeah, I think that's like a decent, like, I liked it because I think it has a decent how to do logs in a microservice architecture if that's you. But I feel like it was pretty basic too. Maybe not as good as I thought it was going to be. If you think there's a particularly fun article to read next week, please let me know and I will I'll put it in the queue. It's hard. I can't read them ahead of time or else I'm not reading with you guys. So please make sure to share those on the Discord or let me know.